Imagine if there was an AI assistant that could quickly answer simple questions and also engage in deep thinking when needed. What kind of experience would that be? On February 24th, 2025, Anthropic released Claude 3.7 Sonnet, which might have provided the answer. This video will provide a detailed explanation of this latest model from Anthropic. The most notable feature of Claude 3.7 Sonnet is its unification of the functionalities of general large language models, LLMs, and reasoning models. Unlike other solutions on the market that require separate deployment of reasoning models, Claude 3.7 Sonnet allows users to freely choose between instant response or deep thinking modes based on actual needs. This design philosophy stems from the imitation of human cognition, just as we use the same brain for quick reactions and deep thinking. In terms of technical implementation, Claude 3.7 Sonnet provides developers with fine-grained control capabilities. Through the API, developers can set a token limit for the model's thinking up to a maximum of 128,000 tokens. This means developers can find a balance between response speed, cost, and answer quality based on specific scenarios. That it is worth noting that this extended thinking capability does not involve switching to a separate independent model, but rather allows the same model to dedicate more time and computational resources to thinking about the problem. Similar to how humans invest more cognitive effort when faced with complex problems, this approach ensures flexibility and adaptability in handling diverse use cases. One interesting feature is that the model's thought process is visible. This transparency not only helps users understand and verify the model's answers, but also allows researchers to discover that the model's way of thinking is strikingly similar to how human experts solve complex problems, exploring multiple different angles and repeatedly checking answers. However, this visibility also brings some challenges, such as the possibility of incomplete or misleading intermediate thoughts during the thinking process, which is a natural phenomenon in deep thinking processes. In terms of performance, third-party evaluations have shown significant improvements in the software engineering capability test, SWE Bench verified. Claude 3.7 Sonnet achieved a base accuracy of 62.3%, which could be increased to 70.3% with custom scaffolding. This result far surpasses other mainstream models, including OpenAI's Model o3 Mini High 49.3% and DeepSeek R1 49.2%. In the tool usage ability test, TU Bench, the model also performed excellently. In the retail scenario test, Claude 3.7 Sonnet achieved an accuracy rate of 81.2%, which is higher than OpenAI o1 73.5% and Claude 3.5 71.5% of the aviation business scenario. Although the overall accuracy rate generally decreased, Claude 3.7 Sonnet still led the competition with a score of 58.4%, such as OpenAI's o1 54.2%. In other key tests, the model also demonstrated comprehensive capabilities in the graduate-level reasoning test, GPQA Diamond. Claude 3.7 Sonnet achieved an accuracy of 84.8% when the extended thinking mode was activated, a significant improvement over the standard mode's 78.2%, also surpassing OpenAI o1's 78.0%. In the instruction following ability test, IF eval, the model achieved a high score of 93.2%, not only significantly better than DeepSeek R1's 83.3%, but also surpassing its predecessor Claude 3.5's 90.2%. It is particularly worth mentioning that in the multilingual question answering test, MMLU, the model achieved an excellent score of 86.1%, comparable to OpenAI o1's 87.7%, while significantly leading OpenAI o3 Mini High's 79.5%, demonstrating strong cross-language understanding capabilities. It is worth noting that Anthropic took a pragmatic direction in developing this model. They did not overly focus on academic problems, such as math competition questions, but instead prioritized practical use cases for enterprises. This can also be seen from the test results of the high school math competition, AIM 2024, when the extended thinking mode is not enabled. Claude 3.7 Sonnet scored 23.3%, significantly lower than other models such as OpenAI o3 Mini, highs 87.3%. This choice may affect the model's performance in certain specialized fields, but may better align with the needs of most users. Along with the model release, there is also an agent programming tool called Claude Code. This tool is currently in a limited research preview phase that IT can search and read code, edit files, write and run tests, and even submit code to GitHub. Early tests show that it can reduce tasks that originally took over 45 minutes to a single operation. This could significantly improve development efficiency. In terms of security, Claude 3.7 Sonnet has undergone extensive testing and evaluation. Compared to the previous generation, the new model is more accurate in distinguishing between harmful and benign requests, with unnecessary rejections reduced by 45% at the same time. The model has also enhanced its protection capabilities against prompt injection attacks. In terms of usage cost, Claude 3.7 Sonnet maintains the same dual pricing structure as its predecessor. Input costs $3 per million tokens and output costs $15 per million tokens. Now, it is worth noting that thinking tokens generated in thinking mode are counted as output tokens and charged at $15 per million tokens. This model is available in all Claude plans, including the free version, Pro, Team, and Enterprise versions, and can also be accessed via the Anthropic API, Amazon Bedrock, and Google Cloud's Vertex AI. However, it should be noted that extended thinking mode is not included in the free version. From a longer-term perspective, Claude 3.7 Sonnet may represent an attempt for AI assistants to develop towards greater flexibility and intelligence, that be why integrating rapid response and deep thinking into the same model. It may provide a new direction for the development of future AI systems. Of course, as a newly released model, the actual performance of Claude 3.7 Sonnet still requires more user testing. Its advantages and limitations in different scenarios, as well as its practical differences compared to other models, require more practice to verify. Finally, we look forward to seeing how this model performs in practical applications and the inspiration it may bring to the development of AI technology. If you're interested in this topic, feel free to share your thoughts in the comment section. Thank you for watching, and we'll see you in the next episode.